This is about the sum and difference formulas. See section 6.5 in the textbook. That's on page 515. So I hope you have opened your textbook up to that section right now and page. There are 4 important formulas that come in 2 pairs. One pair is for the cosine of the sum, cosine of alpha plus beta, the cosine of the difference, cosine of alpha minus beta. The other pair is similar, but of course it's for the sine function. Rather than write them all out here, please turn your textbook to page 524. You'll notice here that there are also formulas for the tangent of alpha plus beta and tangent of alpha minus beta. So they're there, but they're not quite as important as the other 4. For this class, you'll need to memorize the 4 formulas and use them. You don't need to worry about the proof, but I just want to point out back here on page 515 that the proof is just kind of, you muck around with some triangles, and you use basic geometry right down here, side angle side. Over on the next page, you find out that the proof uses a distance formula and a lot of algebra, and that's how the formula is derived. So don't worry about the proof, just know that it basically comes from basic geometry. You should memorize the 4 formulas. Again, don't worry about the tangent ones. When I memorize these or try to recall them, I always start with the sine of alpha plus beta. That's the most symmetrical one. So notice how here with the sine we have a plus and a plus, and then over here we have minus, minus. And then the other these things are in sync, right? Sine alpha, cosine beta, sine alpha, cosine beta, cosine sine, cosine sine. So those are in the same position. The only difference is the plus minus. Now with the cosine, it's very similar, except there's a swap-aroo here of the signs. It's the minus plus, instead of like it was for the sine with the plus minus. And then instead of having 2 different functions like we did here, sine and cosine, we have the same function, cosine, cosine, sine, sine, cosine, cosine, sine, sine. I hope that helps you see the big picture. Let me just do this one here, sine of alpha plus beta. So we've got sine of alpha plus beta. So this one is going to be the plus, right? And then we have, I'm just going to use S and C, sine, cosine. That's from here, right? Sine, cosine. And then cosine, sine. And then notice throughout all of these we have the same alpha, beta, alpha before beta, alpha before beta, everywhere, alpha before beta. Here's something I think is kind of neat about the addition formula. Let's take alpha equal to beta equal 1 degree. Now suppose that by some magic you knew that the sine of 1 degree was this number here, and the cosine of 1 degree was that number there. You know, as a reality check, 1 degree is a pretty small number, and so the x-coordinate here, which is cosine on the unit circle, is going to be close to 1, and the y-coordinate, which is the sine, is going to be kind of a smallish number. So we pretend we know the sine and cosine of 1 degree, and now you might say, okay, so what's the sine of 2 degrees? 2 is 1 plus 1. Well, you might kind of incorrectly say, yeah, it's sine of 1 degree plus sine of 1 degree. Well, that's wrong, right? You can't say the sine of 1 plus 1 degree is sine of 1 plus sine of 1, because look up here. Here's our sine of 1, and here's our sine of 1. But we have to worry about this cosine now, cosine of 1 and cosine of 1, right? So you've got to bring these guys down here into their places, cosine of 1 degree and cosine of 1 degree, to make the formula correct. See, now that's right. sine of 1 degree plus the sine of 1 degree is not just sine of 1 plus sine of 1, but you have these correction factors in here. So now we know the sine of 2 degrees because we are pretending we know the sine and cosine of 1 degree. And we, of course, know the addition formula. So since we know the sine of 1 degree and cosine of 1 degree, we piece that together to get the sine of 2 degrees. So now you can ask, what about the sine of 3 degrees? Well, 3 is 2 plus 1. So that means that we can just keep on chugging away here. This would be using the addition formula. The sine of 2, which we figured out earlier, cosine of 1, which we are pretending that we know, plus cosine of alpha, cosine of 2 degrees, which we can also get from the addition formula, just like we got the sine of 2 degrees times the sine of 1 degree. So we know the sine of 3 degrees because we know the sine and cosine of 1 degree and therefore 2 degrees. And in that way, you can keep on plugging along and you can get the sine of 4 degrees and etc. The sine of 78 degrees if you had patience. So that means that the sine and cosine addition formulas, if you know the sine and cosine of 1 degree, you can, by a lot of arithmetic and algebra, at least in principle, figure out the sine of any number of degrees. Now, when a calculator or a computer actually calculates the sine of 315 degrees, it doesn't actually go through this staging process. It has other rules and algorithms to do that, but I think it's just kind of a neat conceptual thing that comes out of the sine and addition, the addition laws for sine and cosine.